So now dear student, we are going to discuss question number 7.12, clear? And my dear student, this question is actually conceptual question and definitely a little bit lengthy one, but this question will provide you more concept, clear? So actually concentrate on this question. In this question it is given to you an LC circuit contains a 20 millihenry inductor and a 50 microfarad capacitor with an initial charge of 10 millicoulomb, clear? So first whatever is given to you, first we are drawing that one, an LC circuit given 20 millihenry and 50 microfarad capacitor, clear? So let's suppose if I drawing here, let's suppose I can say this is inductor, clear? And I am saying here we have capacitor, clear? And it is given here value of L we have, this is 20 millihenry, clear? And value of capacitor, this is given to you 50 microfarad, clear to you, clear? So 20 millihenry and 50 microfarad, and it is given initial charge on a capacitor, that is 10 millicoulomb, clear? So I can write here initial charge means we can see maximum charge that can be stored on a charge, this is given to you 10 millicoulomb, 10 millicoulomb, clear to you, 10 millicoulomb. Now in this question given the resistance of a circuit is negligible, it means we will not add here any element of resistance, clear? And it is also given let the instant the circuit is closed be t equal to 0. अभी just मैंने सर्किट को क्लोज किया है तो क्या होगा बेटा, LC oscillation, yes or no? क्योंकि सीरीज सर्किट में केवल कैपेसिटर है and we can say we have only inductance and we have only capacitor, clear? So definitely here we will find some oscillations, oscillation in between capacitor and inductor, clear to you? So now we can say part number A, it is given to you what is the total energy stored initially, clear? And is it conserved during LC oscillation, clear? So now concentrate here, just a minute. Yes, first of all our objective here is to find total energy stored in a capacitor. So I can say, let's suppose here I am saying, let's suppose this is part A, initial energy stored, it is given by Q naught square divided by 2C, clear? Value of Q naught, value of Q naught we have, this is 10 millicoulomb, so I can say this is 10 to the power minus 2, yes or no? 10 into 10 to the power minus 3, so this is 10 to the power minus 2 whole square divided by, I can say 250 into 10 to the power minus 6, clear? So from here we can find initial energy stored in a capacitor 10 to the power minus 4 divided by I can say this is 100, we can see this one is 100 multiply 10 to the power minus 6, clear? From here you can see when this 10 to the power minus 6 goes to numerator, it becomes 10 to the power 2, and finally we are getting initial energy stored, this is equal to 1 joule, clear to everyone? So this is answer of part number A. Now in second part it is given to you, yes, actually we have one more thing, is it conserved during LC oscillation? Yes. Actually initially all the charge is stored on the plates of a capacitor, clear? As we connect inductor, some charge will flow from capacitor and it is actually stored as a magnetic energy in an inductor, clear? So definitely some of energy of capacitor is shared shared with the inductor, clear? But if I am talking about total energy of the system, so total energy, or we can say sum of we can say electrostatic energy and magnetic energy, that total sum always remains constant, clear? So now we can say here, so we can say total amount of energy always remains, this is equal to 1 joule, clear to everyone? Yes. So this is all about part number A. Now if I talk about part number B, what is the natural frequency of this circuit, clear? Now you can say this is LC oscillation, so how can we find here natural frequency? Natural frequency is given by omega equal to 1 upon under root of LC, clear? So from here we can write like this, this is 1 divided by under root of L, L is given to you, yes, 20 millihenry, so 20 into 10 to the power minus 3 multiply C, C is given to you 50 microfarad, so 50 into 10 to the power minus 6, clear? So from here I can write like this, value of omega, this is given by we can say 20 multiply 50, this is 1000 and this one is cancelled out, and finally this is 10 to the power minus 6. So I can say, we can write like this is equal to 10 to the power minus 3. Clear? So from here you can write like this, omega may be written like this 2 pi f, and this is equal to 1 upon 10 to the power minus 3. Clear? Or we can write like this, f, this should be given by 1000 divide by 2 pi, we can say pi value we have 3.14. Clear? So from here we can see value of f, this is 1000 divided by 6.28. Clear? Now approximately I am taking this is equal to 6. Definitely this value is more than 6. I can say this is, you can take 6.25 also. Clear? But I am taking here, let's suppose 6. So if I am taking it 6, then we can see near about we are getting this is 500 divided by 3. Clear? And from here you can say, here you will get 166 point something. But so here you are getting this value almost 166.6 hertz. Clear? But now you can see actually here we are having value 6.28. It means definitely I can say here we will find this frequency that is less than 166, or if you exactly calculate here you will find this value is very close to 160 hertz. Clear? So I can say natural frequency of this circuit, it is given by 160 hertz. Clear to everyone? Yes. Now we can say what is part number C. Clear? So now I think part number A and B is clear to you. Yes. Now we are going to discuss at what time is energy stored completely electrical first and completely magnetic. Clear? So now concentrate. Now I am just actually now we are going to discuss part number 3. Clear? Part number 3 is given to you at what time the energy stored is completely electrical, number 1, and completely magnetic. Clear? So concentrate on a screen. Let's suppose here I am saying, let's suppose this is inductor. Clear? And let's suppose I am having here this capacitor. Let's suppose all the energy stored that is completely electrical. It means I can say all the charges that is present on a capacitor. So I am telling here this is plus minus Q naught. Yes or no? Charge that is present on this capacitor Q, this is equal to plus minus Q naught. Clear? So now we can say when we are talking about LC oscillation, the expression of charge that is flowing in NC oscillation, this is given by one expression, Q equal to Q naught cos of, I can say, omega t. Clear to everyone? Q equal to Q naught cos of omega t. So it is also given here all the energy that is stored is a electrical energy. Electrical energy means we are talking first about part number 1. Electrical energy means I can say this value Q, it is equal to plus minus Q naught. So plus minus Q naught, this is equal to Q naught and cos of omega t. Clear? So from here I can write like this, plus minus Q naught, this is equal to Q naught cos of, I can say this is 2 pi by t and multiplied with t. Clear? So now we can say here this Q naught and Q naught, this one cancel out. So we can write like this, this is cos of 2 pi by t multiply t, this is equal to plus minus 1. Clear? Or we can also write like this, this is cos of 2 pi by t multiply t, this is equal to plus minus, I can say this is cos 0. Clear? Now we can say here we can write this is cos 0, it may be we can say cos pi. Yes or no? We can say this is a cos 2 pi. Clear? So from here we can write here this value like this, cos of 2 pi by t multiply t, this should be equal to, I can say this is equal to cos of n pi. Clear? You can place here value of n 0, 1, 2, 3 and so on. Clear? So from here we can say 2 pi by t multiply t, this is given by n pi. Clear? We can say pi and pi, this one is cancelled out. Clear? So from here we can write like this, value of t, this is given by n t by 2. Clear? Now if I place here n equal to 0, at the time I am getting t equal to t by t equal to 0. Clear? T equal to 0. So t equal to 0. Clear? Now when I am placing here n equal to 1, I am getting here t, this is equal to t by 2. Clear? If I am placing here n equal to 2, I am getting here t, this is equal to T. Clear? Similarly, you can say when I am saying n equal to 3, T is given by 3T by 2. Clear to you? So you can say here we will find at time t equal to 0 because it is given initially all charge present in a capacitor. So I can say all energy this is stored is electrical energy. Clear? But if I am talking about t by 2 means after half of cycle, again all charge is stored on a capacitor and again we have energy that is electrical. After t by 2 more, we can say at time t, I can say again charge stored is only on capacitor. So I can say we have only energy that is related energy and that is only electrical energy. Clear? So this is all about part number first. Clear to everyone? Now if I am talking about part number second, clear? In part number second it is given, now we have to find time at which all energy that is stored is magnetic energy. Clear? So magnetic energy, now my objective here is to find magnetic energy. So how can we find? We can say whenever all energy is magnetic energy, at that time I can say charge stored in a capacitor that is 0. Clear? So I can write like this general expression we have Q equal to Q naught cos of omega t. Clear? This value of Q is 0. So I can say Q naught cos of omega t, this is equal to 0. Clear? Now you can say whenever we get this value 0, cos pi by 2, cos 3 pi by 2. Clear? So if I write here generalize, I can say cos 2 pi by t into t, this is equal to cos 2n plus 1, this is pi by 2. Clear? Now if you place value n equal to 0, I can say cos pi by 2. If you place 1, 3 pi by 2, and in all conditions you are getting 0. So from here I can say this is 2 pi by t, this is given by 2n plus 1 and this is pi by 2. Clear? From here you can say pi and pi, this one is cancelled out. So value of t, this is given by 2n plus 1 and that is capital T by 4. Clear? Now if you place n equal to 0, clear? N equal to 0 you will get here, this is T by 4. Clear? It means if let's suppose total time period of this oscillation is capital T, then in 1/4 of a time all the energy that is present here, that is magnetic energy. Clear? Or you can say all electric energy in time 0 to T by 4 is converting into magnetic energy. Clear? Similarly you can say if we have value n equal to 1, n equal to 1 means we can say this is 3, so this is given by 3T by 4. Clear? Let's suppose we are having value n, this is equal to 2, I can say this is given by 5T by 4, I can say this is 7T by 4 and so on. Clear to everyone? So this is the time where you will find all energy stored in LC oscillation in this circuit is only magnetic energy. Clear to everyone? So this is all about part number C. Clear? Yes. Now we can say we have completely solved here part number C. Now we are going to discuss part number D. Clear? So part number D means we can see at what time is the total energy shared equally between inductor and capacitor. Clear? So now concentrate. Yes. Now concentrate. Let's suppose I am taking here, this is inductor and let's suppose I am saying this is capacitor. Clear? I can say this is C and this is L. It is given in a question that energy stored in a capacitor is half of the total energy stored. Clear? Yes, question is given to you. At what times is the total energy shared equally between inductor and capacitor? It means what I can say. If we talk about total energy, total initial energy, I can say it is given by Q naught square divided by 2C. You know very well. Let's suppose this is plus, total charge present is Q naught, so Q naught square divided by 2C. But it is given in a question that now this energy is equally distributed in capacitor as well as in this inductor. Clear? So I can say let's suppose at any instant charge present on this capacitor is Q. So I can say Q square by 2C, this is given by 1 by 2 of total energy present. Clear? Clear? I am assuming here this Q is the charge present at any time t. So we can say this energy is half of total energy. Clear? So from here what we can get, 2C and 2C cancel out. From here we can write like this, this is equal to plus minus Q naught by root 2. Clear? Q is given by what? Q is given by, this is equal to plus minus Q naught by root 2. Clear? Now we can say, we can write like this, Q, this is given by Q naught, I can say that is cos of omega t. Clear? So if I write here value Q, I can say this is equal to plus minus Q naught by root 2, this is given by Q naught, I can say this is cos of omega t. Clear? So from here we can write like this Q naught and Q naught, this one is cancelled out. Clear? So from here you can see, we can write like this, cos of omega t, this is equal to, I can say either cos pi by 4 or you can say this is cos 3 pi by 4. Clear? But let's suppose if I generalize this relation, at that time I can write like this, omega t I can say this is 2 pi by t multiply t, this should be equal to, listen carefully how I am writing, n pi plus, clear, what I am saying, n pi clear, n pi plus, I can say pi by 4 or I can say 3 pi by 4. Clear to you? Clear? You can also write like this is plus minus. Clear? So now from here you can write like this, if you take here pi, this pi and pi, this one is cancelled out, and from here you can say value of t you are getting, this is t by 2, clear, and plus minus, listen carefully, and plus minus, I can say 1 by 4 or I can say this is 3 by 4. Clear? So from here we can say t, this is given by t by 2. Clear? Now I can say if we take here LCM, clear, or first you can say n plus minus 1 by 4 or 3 by 4. Now you can say, sir, why you are writing? Now we are actually saying here two different times. Clear? So now we can say t can be written as, first I am taking here LCM 4, so 4n plus 4, and I can say this is given by t by 8 and this one is what, 4n plus 1. Clear? I can also say write like this, t2, this is given by, again if you are taking here LCM t by, if you are taking LCM 4, it becomes 4n plus 3. Clear? So like this we can find here two different times. Clear? So now we can see, actually here we will find two times. So let's suppose if you place here n equal to 0, so you are getting here time, we can say first t by 8. Clear? At the time you are getting this is 3t by 8. Clear? If you place 1, now you can say at the time you are getting here 5t by 8. Clear? If you place here 1, you are getting here this is 7t by 8, and we can say if you are placing 2, I can say 9t by 8, and here you are getting 11t by 8. Clear? So we can say these are the times at which you will find energy stored in capacitor on an inductor is half of the total energy present. Clear? So this is again a very good part. Again I am saying this is very conceptual, so very good part. Now we are going to discuss part number D. Part number D is clear to you? Yes. Now we are going to discuss part number E. If a resistor is inserted in the circuit, how much energy is eventually dissipated as heat? Now listen carefully. In LC oscillation, in actually energy is conserved, total energy is conserved because there is no any resistance element is present. But what will happen when resistance is present? So when resistance is present, at that time I can say whenever a charge flow, definitely some of heat will be generated, and slowly I can say total energy is going to be decreased, and at one time all energy is dissipated in the form of heat. Clear? So if you connect a resistor, you will not find here LC oscillation, or if you find here LC oscillation, at the time the magnitude is slowly decreases, and finally all energy is converting into heat. Clear? So this is all about this question. Clear?